For cantilever suspensions, what is better? A shock motion that moves more than the wheel, or the wheel motion, or vice versa? Yeah, so what Michael's talking about there is when you've got an inboard type suspension. So most road car suspensions are all going to be direct acting in that you've got, say, a lower control arm and a damper mounted directly to it, or in the case of a McPherson strut like we've got here, we've got the hub mounted directly to the strut. So it's directly acting through the spring and damper, and what Michael's talking about, which is something you see a lot on single seaters, prototypes, stuff like that. You've got the springs and dampers mounted inboard inside the tub or close to the center of the car, and they're usually actuated by a series of rockers and push rods. So his question is there, is it better to have the wheel versus spring move more or less? So often it's not, there are a couple of ways you can approach this question. It often comes back more to a practicality and a packaging thing. So one of the things we're often trying to do in motor racing, if you're going through the trouble of designing a whole system of cantilevered suspension, one of the things you're often trying to do is minimize the amount of weight, and you're often also trying to deal with packaging challenges as well. So you don't usually have a whole lot of room to fit these things in. So what that typically means is you end up with smaller, shorter stroke dampers. So inevitably that's going to mean that you have more wheel travel to damper ratio travel. Now that's one aspect of it, is thinking about the packaging implications. So that's automatically going to tend to mean you have more wheel travel for a small amount of damper travel. The other thing that you've got to be careful of if you get too extreme in that direction is that your damper speed's ending up coming down, because you've got this big leverage ratio and your wheel's moving this much and your damper's only moving this much. That means that the velocities of the piston inside the damper are going to be dropping a lot. The downside with that is, well, with dampers, essentially they're only sensitive to velocity. They're not sensitive to position like a spring is. They only give a force in response to how fast they're going, not how far they're moving. The reason I say that's important is because if we've got these big motion ratio differences, if you end up with the damper not moving a lot for a lot of wheel movement, it means the damping can actually start to not be as responsive or not respond as quickly to inputs, which is a big downside, especially in the low speed range when you're talking about driver inputs, things like braking and turning and stuff like that. It tends to make the dampers less responsive. So from that perspective, you know, running a 1-to-1 motion ratio, or, you know, you don't need to go to the point of having the damper moving more than the spring, but typically, you know, you're wanting to get that motion ratio closer to 1-to-1 rather than being getting it too fast, so your damping speeds are going to reduce as that motion ratio increases a long way. That question was taken from one of our free live lessons. If you like free stuff and you want to expand your knowledge, click the link in the description to claim your free spot to our next live lesson. You'll learn about optimizing the performance and handling of your car on the racetrack, as well as improving your skills behind the wheel. Plus, you'll have the chance to ask your own questions, which we'll be answering live.